how do we find the differential equation of motion of a point particle falling under the influence of gravity using the Euler-Lagrange equation? Our first step to solve this problem is to find the Lagrangian, which consists of the kinetic energy of the system minus the potential energy of the system. To find the kinetic energy of this point particle, we are only talking about the translational kinetic energy, which is 1/2 mv squared. V in this case is going to be y dot, as our system coordinate we're going to call the up and down direction y. And the first derivative of this displacement y is going to be the velocity. To find the potential energy of the system, we just use the equation mgh. And in this case, h is just going to be y, as that's our coordinate, generalized coordinate that we're going to be using. To find the Lagrangian, we just put these two kinetic energy and potential energies together. So it's going to be 1/2 m y dot squared minus mgy. Now that we have the Lagrangian, we can now plug this into the Euler-Lagrange equation, do our partial derivatives and time derivatives, and have our differential equation of motion. So let's first do the first term inside this parentheses, where the partial of Lagrangian with respect to the generalized coordinate dot is going to be m y dot. As you can only find a derivative of the first term, which has the y dot, and the second term just goes to 0, as there's no y dot. We can find the time derivative of this term, which is what we need to do here, and just add a second dot right here, as the time derivative of my dot is just my double dot. To do the second term, partial Lagrangian with respect to y is just going to be minus mg, as you can only find a derivative of the second term right here. And the y just turns into 1, and you're left with minus mg. We can put these two terms together into the Lagrangian. So we find our differential equation of motion for a particle would be my double dot minus, so there's two minuses, they cancel out to a positive, mg equals 0. So this is our differential equation of motion that we can solve if we want to integrate twice to get the velocity as a function of time, as well as the displacement of the particle with respect to time. You can kind of see it right now already. If you cancel out the m's and move to g to the other side, we get y double dot, which is equivalent to acceleration, equals minus g, which we can integrate twice and get our other equations of motion in velocity and displacement.